For decades after the Apollo and Luna missions, the moon kept its secrets hidden, while humanity turned its gaze to other worlds. The last return of lunar samples by the Soviet Union's Luna 24 mission in 1976 marked the end of an era. Then, almost overnight, the lunar race resumed. SpaceX rockets soared into the skies. NASA developed the Artemis program to return astronauts to the moon, and China quietly ventured where no nation had ever gone before. Whispers began about strange discoveries on the far side of the moon. What was truly found beneath its silent dust? And why is everyone racing back? To understand this, let's look at the context. China's lunar exploration is relatively recent, beginning in the early 2000s under the China National Space Administration, CNSA. They designed an ambitious step-by-step plan known as the Chang'e program, named after the Chinese moon goddess. Chang'e 1, launched in 2007, was China's first lunar orbiter. It created a 3D map of the entire moon and analyzed soil composition. Importantly, its instruments detected signs of helium-3 in the lunar regolith, a rare isotope that could fuel future nuclear fusion reactors. In 2010, Chang'e 2 followed, carrying higher-resolution cameras. It orbited just 15 kilometers, 9 miles above the surface, to photograph potential landing sites for upcoming missions. Then, in December 2013, China made history. Chang'e 3 performed the first soft landing on the moon since 1976, touching down in Mare Imbrium. Its U2 rover, meaning Jade Rabbit, explored the Gray Plains, carrying the first lunar-based ultraviolet telescope. But China's ambitions reached even further. In January 2019, Chang'e 4 became the first spacecraft ever to land on the far side of the moon, a region no nation had explored. The far side is significant. It permanently faces away from Earth, hidden from our radio signals and communications. Landing there required innovation. China launched Kuiqiao, a relay satellite stationed at the Earth-Moon L2 point, maintaining a line of sight with both Earth and Chang'e 4. This relay was crucial for controlling the lander and rover. Chang'e 4 landed in Von Karman crater within the colossal South Pole Aitken Basin, one of the largest and oldest impact structures in the solar system. This ancient, heavily cratered region holds keys to the moon's geological history. The U2-2 rover rolled onto the surface just hours after landing, becoming humanity's first robotic explorer of the far side. Its cameras revealed a pitted, rugged terrain under a pitch-black sky. Unlike the near side's dark lava seas, Maria, the far side has a thicker crust and is dominated by craters. One of U2-2's intriguing discoveries came in mid-2019. Inside a small crater, it found a mysterious shiny substance. Initially called a gel by Chinese scientists, speculation exploded online, with theories ranging from alien slime to secret technology. Later analysis revealed it was impact melt glass, created when meteorite collisions fused lunar soil and rock into a glossy mass. Another milestone came from Chang'e 4's biosphere experiment. Inside a sealed container, scientists placed cotton seeds, potato seeds, and fruit fly eggs. For the first time in history, a cotton seed sprouted on the moon, proving that Earth life can begin to grow in extraterrestrial environments. Unfortunately, the sprout died when lunar night fell and temperatures dropped drastically. But this experiment demonstrated a glimpse into sustainable future moon habitats. In 2020, China's Chang'e 5 mission returned lunar samples to Earth, the first such retrieval since 1976. Among the materials, scientists discovered a new lunar mineral named Changesite, which also contains traces of helium-3. Helium-3 is incredibly rare on Earth, but abundant in the Moon's regolith, deposited by the solar wind. Theoretical studies suggest that just 100 kilograms, 220 pounds, of helium-3 could power an entire city for a year through nuclear fusion. Some estimates indicate over 1 million tons may exist on the Moon, potentially solving humanity's energy problems for thousands of years, though practical extraction and fusion remain decades away. Beyond resources, the far side offers a perfect site for radio astronomy, shielded from Earth's electromagnetic interference. Future telescopes could explore cosmic phenomena with unprecedented clarity. But China's moon program is not just about science. It reflects geopolitical ambition. While NASA's Artemis program aims to return astronauts to the moon by 2025 and build a base at the lunar South Pole, China plans its own International Lunar Research Station, ILRS, by the 2030s, in partnership with Russia and other nations. Both superpowers focus on the moon's polar regions, rich in water ice. Water is vital. It can be split into hydrogen and oxygen for rocket fuel and life support. A lunar settlement depends on these resources. In 2024, Chang'e 6 returned the first samples from the moon's far side. Upcoming Chang'e 7 and 8 missions will explore the South Pole, searching for ice and testing technologies for 3D printing habitats from lunar soil. As this quiet competition intensifies, questions arise. Who owns lunar resources? Under the 1967 Outer Space Treaty, no nation can claim sovereignty over the moon, but mining rights remain unclear. Future conflicts or new international agreements may define the rules of this new space economy. In the 1960s, the moon race was about flags and footprints. Today, it's about building a foothold for the future, sustainable exploration, scientific advancement, and strategic dominance. As nations and private companies set their sights on the lunar surface, the far side of the moon is no longer in the dark. It has become a proving ground for humanity's next giant leap. In 2024, Chang'e 6 returned the first samples from the moon's far side. Upcoming Chang'e 7 and 8 missions will explore the South Pole, searching for ice and testing technologies for 3D printing habitats from lunar soil. As this quiet competition intensifies, questions arise. Who owns lunar resources? Under the 1967 Outer Space Treaty, no nation can claim sovereignty over the moon, but mining rights remain unclear. Future conflicts or new international agreements may define the rules of this new space economy. In the 1960s, the moon race was about flags and footprints. Today, it's about building a foothold for the future, sustainable exploration, scientific advancement, and strategic dominance. As nations and private companies set their sights on the lunar surface, the far side of the moon is no longer in the dark. It has become a proving ground for humanity's next giant leap.